Welcome to The Explainer. Today, we're going to crack open a kind of digital time capsule. We're going back to 2001 to look at this incredible article that dreamed up a version of the World Wide Web that could actually think.
So let's start with something we've all been through, right? You're trying to plan something. Maybe it's a vacation, or maybe it's something complicated like a bunch of doctor's appointments. And you find yourself jumping between like 10 different tabs, copying and pasting info, and just getting so frustrated that none of these things can just talk to each other. Well, guess what? The people who first built the web, they felt that exact same frustration. And you know that little everyday annoyance? It points to a really deep, fundamental problem with how the web was originally put together. It was an absolute masterpiece of design, yeah, but for a very, very specific user. You and me, human beings. I mean, think about it. When we look at a web page, our brain just fills in all the gaps. We see a string of numbers, we know it's a phone number. We see a name, we know it's a person. But for a computer, it just sees a bunch of characters. So for us, the web was this amazing, vast library. For a machine, it was just a chaotic, meaningless jumble of words.
So what's the fix? Well, that 2001 article laid out this really powerful idea. Not to replace the web, no, but to add a new layer to it, an extension. And they called it the Semantic Web, a web where information is given actual, defined meaning so that computers can finally understand the data they're looking at.
And to really get what they were aiming for, the article tells this great little story about a brother and sister, Pete and Lucy. They've got this really complex task, coordinating medical care for their mom. But instead of spending hours on the phone and pulling their hair out, Lucy just turns to her software agent and tells it to handle the whole thing.
Now this agent, this isn't some far-off science fiction. It's a program that can actually pull off this whole complicated dance because it understands the meaning of the words it's finding online. It knows what in-plan provider means. It knows how to read ratings. And it knows how to juggle everyone's calendars to find that one perfect open slot.
Which, of course, brings us to the billion-dollar question. How on earth do you teach a computer what things actually mean? How do you give information a structure that a machine can use time and time again without messing it up?
Okay, so the first piece of the puzzle is this thing called XML. And you can just think of it like a universal label maker for the internet. It lets anyone creating a web page wrap any little piece of data in a tag that describes what it is. So instead of just seeing 1001, the computer now sees that number wrapped in a label that says, hey, this is a zip code. Boom, all of a sudden that number has context.
But, labels by themselves aren't quite enough. You need some grammar to connect them. And that's where RDF comes in. It's a framework that takes those labels and arranges them into super simple facts a computer can read. Subject, verb, object. Like, Dr. Hartman, that's the subject, works at, that's the verb, University Hospital, the object. You're basically building a language for machines. Now, the next thing you have to do is get rid of any confusion. In English, a word like address can mean a dozen different things. For a computer, that's a total disaster. So the Semantic Web solves this by giving every single concept its own unique ID called a URI. It's like a unique ID card. That way, a mailing address has a totally different ID than a web address, and a machine will never, ever get them confused.
Okay, so we've got our data labeled, we've got a basic grammar, but that just leads to another huge problem. Different websites are going to use different words for the exact same thing.
Exactly, right? If one website's database says zip code and another one says postal code, how does our little software agent know they're talking about the same thing? If you can't build a bridge between those two terms, the whole dream of an automated web just falls apart.
The answer, and this is really the secret sauce of the whole idea, is something called an ontology. And for us, let's just think of it as a universal rulebook, or maybe a translation dictionary for the web. It's just a file living on the web that anybody can point to, and it officially defines what terms mean, and, this is the key, how they relate to each other.
And this is where the magic really happens, because these rulebooks let software agents make logical leaps. For instance, the rulebook might say, Ithaca is a city located in the state of New York. So now an agent doesn't need to be told explicitly that an address is in New York. If it sees the address is in Ithaca, it can infer the rest all on its own. It can make a connection,
So, once you have all the pieces, you've got the labels, the grammar, the unique IDs, and these shared rulebooks, well, the stage is finally set. You can let the software agents loose to solve real, complex problems.
And these agents could do so much more than just a simple search. They could pull in and process info from all over the place, securely trade results with each other, and, get this, they could even prove their work. Imagine an agent showing you the exact data and the exact rules it used to make a decision. You'd have a web built on actual, verifiable trust. But the vision? It was so much bigger than just websites on a screen. The idea was to use this exact same system to let the web spill out into the physical world all around us.
I mean, just picture a world where your microwave automatically pulls the perfect cooking instructions right off the food producer's website, or where you answer a phone call and your TV and your smart speaker just know to lower their volume without you doing a thing. That's the kind of world that's possible when our devices stop living in their own little bubbles and start speaking the same language.
But really, the ultimate goal was so much deeper than just making our lives easier. The creators of this vision believed that if anyone, anywhere, could define a concept and link it into this massive, logical web, we could actually start to weave together all of human knowledge. We could create a web that didn't just hold our information, but that helped us understand it in brand new ways.
And so that leaves us with a pretty big question, doesn't it? This was the dream back in 2001. And yeah, we can see little echoes of it today in our search engines and smart assistants, but when you look back at this huge, ambitious vision of a truly intelligent, cooperative web, you have to wonder, how much of it did we actually build? And what parts of that dream are still waiting to be realized?